Hello, class. You are welcome back. We now look at simple interest, compound interest, and some examples. Now, discussing the topic of interest, there are two major types of interest that is known in literature. The first type is a simple interest, and then we have a compound interest. So under simple interest, interest accrues according to the following pattern. The accumulation function, AT, is equal to 1 plus IT, where I is representing your interest and T is representing time. For any integral T, for any integer, T greater than or equal to 0. Now let I be the rate of simple interest and let IN be the effective rate of interest for the end period. Then we have the effective rate of interest being given as our accumulation function at the end of the period minus the accumulation function at the beginning of the period over the accumulation function at the beginning of the period. So if you expand this mathematically, this is what you arrive at, okay? So this is just for your information. How about compound interest? Under compound interest, the interest that is earned, let me go back to simple interest and say something over here. Now with simple interest, practically, in explaining it practically, if you have an amount of say 1,000 Ghana cedis, and then, so let's look at it. Let me illustrate it here. So we want to look at simple interest. Let's define our I as 10%, the interest rate. And then our T we define our T as years, okay. So let's consider a 5-year period of investment. So 5-year investment. So let's take the amount invested to be the principal. T is equal to 1,000. So I don't know, first year. Sorry. Please pardon me. At the end of the first year, the value of your investment will be 1,000 times 1 plus IT, which is equal to 1,000, 1 plus I is 10%, that's 0.01 times T. We're looking at the first year, so T is 1. So if you calculate this, you get 10% of 1,000 is 100. So we have 1,100. At the end of the second year, what do we get? 1,000, 1 plus 0.01 times 2, which is 1,200. At the end of year 3, we have 1,000, 1 plus 0.01 times 3 equals 1,300. At the end of the fourth year, we have 1,000, 1 plus 0.01 times 4 equals 1,400. You realize that over all the years, an interest rate of 100 cedis is earned. So at the end of year 1, we have 1,001. Interest earned is 100. At the end of year 2, we had 1,002. So an extra 100 was earned. At the end of year 3, another extra 100 was earned. So the amount of interest earned in each of the periods is constant. Once it's 10% of interest over your investments of P, you always earn 100 cedis as interest every year. So this is how simple interest works. Let's move on to compound interest. So under compound interest, interest is reinvested to earn additional interest. The theory of compound interest handles the problem by assuming that interest earned is automatically reinvested. So under compound interest, unlike simple interest, where the principal earns interest only throughout the entire period of investment, compound interest, principal keeps earning interest, and for every year, whatever interest you earn, that interest also earns interest in the subsequent years. And compound interest is the most practiced today in our finance sector, all right? So the accumulation function for a constant compound interest is given as AT equals 1 plus I, so all raised to the power T. There's a difference between this and the simple interest. And the effective interest rate is the difference, the amount of interest, okay, that's the difference between what you earned at the end minus what you put in at the beginning, all over what you put in at the beginning, okay? So that's the difference in the amount functions over the amount function at the beginning of the period. And if you simplify on and on, you come back to I, okay? So can we illustrate how a compound interest also works? So we have here compound interest. So we have our interest to be 10%. Then our principal, what we put in is 1,000. So at the end of year one, what happens? The amount of value earned at the end of year one is 1,000 times 1 plus I to the power T, which is equal to 1,000 times 1 plus I is 10%, so 0.01 to the power T is, we are looking at the end of the first year, so T is 1, and that'll give you an amount. Then at the end of the second year, we have 1,000, 1 plus 0.01 to the power 2. Third year, we have 1,000, 1 plus 0.01 to the power 3. In the fourth year, we have 1,000, 1 plus 0.1 to the power 4. So when we do our calculation, you can do it with me. I'm trying to do it on my calculator here, 1.01. So the first one is giving us 1,010. Okay. Then I think I've made a mistake here. It's supposed to be 0.1. Okay, so let me change the interest here, because what I'm writing, 0.01 is 1%, not 10%. So 1%, okay. All right. So I've changed the interest from 10% to 1%. In the case of the second year, we have 1020.0 1. In the case of the third year, we have 1030.3. Then for the fourth year, we have 1040.6. Good. So if you look at these accumulated values, you realize that we are earning the 10 cedis at the end of the first year, but we are earning 20.1 at the end of the second year, 30.3, and then 40.6 respectively at the end of the second, third, and fourth years. So with compound interest, you are not earning a fixed amount of interest every period, because if you earn 10 at the end of year 1 and you earn 20.1 at the end of year 2, it means that the difference is 10.1. So you earned 10 at the end of year 1, but from year 1 to year 2, you earn 10.1. Okay. And from year 2 to year 3, you earn 10.2. So for compound interest, the interest whatever interest, the 10 cedis here, it also earned interest. So in second year, the 1,000 earned interest. Okay, the 1,000 earned interest of 10. And then the 10 cedis of interest here also earned interest, and 10% of, no, 1%, 0.01 times 10 is 0.1. 1% of 10 cedis is 0.1. That's how come we have 20.1 here. The difference between these two is 1020.1 minus 1010 is 10.1. So the 1,000 cedis earned this interest of 10, and then the 10 cedis of interest here earned this interest of 0.1. So here we see that apart from the principal earning interest as time progresses, the interest earned for every period also earns interest. Okay. We want to look at the difference between simple and compound interest. So same results over one measurement period. If you're looking at just a period of say 1 year, then whether you use compound interest or simple interest, you get the same accumulated value at the end of the period. Okay, so you can try it to see. But under simple interest, if it's more than a period of 1 year, then you earn more under compound interest, but less under simple interest. Because if you are considering more than 1 year, then interest earned within the first year will earn an interest and so on. But under simple interest doesn't earn any interest. It's only the principal that keeps earning interest over the periods. Now, as an example, it said find the accumulated value of 2,000 invested for 4 years if the rate of simple interest and compound interest is 8%. So you can try it, but you realize that if you try simple interest using the formula, see here, you put in 4, okay? You get 2,000, 1 plus interest is 8%, so 0.08 times C, and the value is 2640. But for compound interest, you are getting 2,000 times 1.08 to the power 4, which is 2720.98. So you realize that a compound interest over a period of 4, you are earning more than simple interest. So usually in most of our financial sector practice, like investments, compound interest is mostly practiced, especially when the investment is being done for more than one period. So let's end this session here, and I'll see you in the next session.